Good morning students, welcome back to the session. Today we are going to discuss the relation between zeros and coefficients of a cubic polynomial. In previous session we discussed the relation between zeros and coefficients of a linear polynomial as well as quadratic polynomial. For linear polynomial, we have only one zero, that 0 x equals to minus b by a. So, where b is the constant term and a is the coefficient of x. Then, for a quadratic polynomial, the degree of the polynomial is 2. So, we get at the most 2 zeros. We get at the most 2 zeros. So, these 2 zeros will take as alpha and beta. These alpha and beta are the Greek letters. Here, sum of the zeros equals to minus b by a and product of the zeros equals to c by a. So, using sum and product, we can frame a quadratic polynomial and even we can find the zeros of the polynomial. Today we are going to discuss the relation between zeros and coefficients of a cubic polynomial. The general form of a cubic polynomial is ax square plus ax cube plus bx square plus cx plus d, where a is not equal to 0. The general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a is not equal to 0, where a, b, c, d are the real numbers. So, before going to the relationship between zeros and coefficients, what are the types of the graphs we get in this cubic polynomial? Let us take an example. Take a cubic polynomial p of x equals to x cube plus x square plus x plus 1 is a cubic polynomial. Now, we'll plot graph for this polynomial. So, let us take y equals to x cube plus x square plus x plus 1. Now, put x as 0, x equals to 0, then y equals to 0, 0, 0 plus 1. So, when x is 0, y is 1. When x is 1, then y is 1 plus 1 plus 1 plus 1. So, y is 4. Similarly, when x is minus 1, then you will get here minus 1 plus 1 minus 1 plus 1. So, which is 0. Y equals to 0. Similarly, you take x equals to 2. When x is 2, what you will get? 2 cube 8, 2 square 4, 2 plus 1, 8 plus 2, 10, 4, 15. So, y equals to 15. When x is minus 2, then we will get minus 2 whole cube is minus 8. Then minus 2 whole square is plus 4, minus 2 plus 1. So, minus 2 minus 8 minus 10 plus 5, which is minus 5. So, y equals to minus 5. Now, I am going to plot graph for these points. Okay. Now, vertical axis, y-axis, and the horizontal axis is x-axis. Okay. 1, 2, 3. Here minus 1 negative, and here also negative coordinates, and here positive coordinates. Okay. Now, when x is 0, now see here 1, 2, 3, minus 1, minus 2, minus 3. So, negative coordinate here, I will 2, 4, 6, 8, 10, then 14, 16, 18. Now, when x is 0, y is 1. When x is 0, y is 1 here. When x is 0, y is 1. When x is 1, y is 4. Y is 4 here. Then when x is minus 1, y is 0. X is minus 1, y is 0. And x is 2, y is 15. 15 between 14 and 16. Then x is minus 2, y is minus 5. Y is minus 5. Now join these points. See here. The graph of a cubic polynomial is a curve. And for quadratic polynomial, we got parabola, but here we will get only a curve. Now, this curve intersects x-axis at how many points? So, this curve intersects x-axis at only one point. So, this is the point of intersection. So, the curve, the graph of this polynomial intersect x-axis at one point. So, we say that the above cubic polynomial has only 1 0. So, this polynomial has 1 0. Okay, we will take one more example. So, another example, x cube minus x square. This is also a cubic polynomial where degree of the polynomial is 3. Okay. Now, in this polynomial p of x, the degree is 3. So, it is a cubic polynomial. Now, we will plot graph for this polynomial by taking x as 0. When x is 0, then y is also 0. When x is 1, then y is 1 minus 1, that is 0. See here, 1 minus 1, which is 0. When x is minus 1, then y equals to minus 1 whole cube minus of minus 1 whole square. So, minus 1, okay, then minus 1 whole square is plus 1, so which is minus 2. So, y is minus 2. If you take x as 2, then you will get 2 cube minus 2 square. 2 cube is 8. Minus 4, which is 4. So, y equals to 4. If you take x as minus 2, then y equals to minus 2 whole cube minus of minus 2 whole square. So, which is minus 8. 2 square is 4. So, minus 8 minus 4, which is minus 12. So, y is minus 12. Now, I am going to plot graph for this polynomial. Again, vertical axis y and horizontal axis x. So, these are all the positive coordinates, negative coordinates here. So, here I will take minus 2, minus 4, minus 6, here plus. Okay. Now, here in the negative y is minus 12. So, I will mark all the negative integers. Minus 8, minus 10, minus 12. Okay. Now, when x is 0, y is also 0. Here, at this point, both the coordinates are 0. When x is 1, y is 0. Again here. Then, when x is minus 1, y is minus 2. Then x is 2, y is 4. Then x is minus 2, y is minus 12. Now join these points. Again you got a curve which intersect x-axis at 2 points. So this curve intersect x-axis at 2 points. It means that the above polynomial have 2 zeros. So it has 2 zeros. In the previous example, the graph or the curve intersect x-axis at only 1 point. We say that 1 0. But here in this example, we got this curve intersect x-axis at 2 different points. So we say that 2 zeros. Now one more example I will take. Third example. So in this example, that is x cube minus 8 we take. This is also a cubic polynomial. So x cube minus 8. Now y equals to x cube minus 8. Put x as 0. Y is minus 8. Then x is 1. Then y equals to 1 minus 8 is minus 7. Then when x is minus 1, then y equals to minus 1 whole cube is minus 1. Minus 1 minus 8 is minus 9. Similarly, x as 2, then you will get 2 cube. 2 cube is 8. 8 minus 8 is 0. So x equals to minus 2, then y equals to minus 2 whole cube is minus 8. Minus 8 minus 8 is minus 16. Okay. Now we plot graph for this. So y-axis and here x-axis. So x-axis. So here minus 2, minus 4, minus 6, minus 8, 10, minus 10, minus 12, minus 14, minus 16, minus 18. Here also take 2, 4, 6, 8. Then minus 2, minus 4, minus 6. Here 2, 4, 6, 8. Okay. Now we locate all these points. When x is 0, y is minus 8. Then, when x is 1, 1 is between 0 and 2, x is 1, y is minus 7. Minus 7 is here between minus 6 and minus 8. Then, x is minus 1 is here between minus 2 and 0. So, which is minus 9. Minus 9 is between minus 8 and minus 10. Then, when x is 2, y is 0. Then, when x is minus 2, then y is minus 16 here. Now, join these points. Again, this curve intersect x-axis at this point at 2. So, it has 1 0. It has 1 0. Suppose the graph, see here, intersect x-axis like this, then what we'll say here? It has 3 zeros. See here. How many zeros? Only 1 zero. This graph intersect x-axis at only 1 point. So it has 1 zero. But here the graph intersect x-axis at 3 different points. So it has 3 zeros. Yes. So therefore any cubic polynomial, if you take any cubic polynomial, it has at the most 3 zeros. Sometimes you will get 1 zero, sometimes you will get 2, at the most 3 zeros. Maximum means 3 zeros. Sometimes you will not get zeros only. So any cubic in general we say that cubic polynomial has at the most 3 zeros. Now we move to relation between zeros and its coefficients. The 3 zeros of the cubic polynomial are alpha, beta and gamma. Let the 3 zeros of the polynomial are alpha, beta and gamma. So these three are the zeros of the polynomial. Then sum of the zeros. That is alpha plus beta plus gamma equals to minus b by a. Sum of the zeros is alpha plus beta plus gamma equals to minus b by a, where b is the coefficient of x square and a is the coefficient of x cube. Then sum of the product of the two zeros taken at a time. Sum of the products of the two zeros taken at a time. That is alpha beta, beta gamma plus gamma alpha equals to c by a. Here c is coefficient of x and a is the coefficient of x cube. Then product of the zeros. Is alpha beta gamma, that is alpha into beta into gamma equals to minus d by a, where d is the constant term and a is the coefficient of x cube. So the general form of a cubic polynomial is ax cube plus bx square plus cx plus d. This is the general form of a cubic polynomial where a is not equal to 0. So any cubic polynomial at the most 3 zeros. And these 3 zeros will take as alpha, beta and gamma. Once again they are the Greek letters. So sum of the zeros, that is alpha plus beta plus gamma equals to minus b by a, where b is the coefficient of x square and a is the coefficient of x cube. Then sum of the products of the two zeros taken at a time. So two zeros we have to take the product and add it. So alpha beta plus beta gamma plus gamma alpha equals to C by A, where C is the coefficient of x and A is the coefficient of x cube. Then product of the zeros, that is alpha beta gamma equals to minus D by A, where D is the constant term and A is the coefficient of x cube. Using these three relations, we can find a cubic polynomial. Even we can find the zeros of the polynomial. Now, let us take some examples for better understanding. If the zeros of a cubic polynomial, first example, the zeros of a cubic polynomial x cube minus 6x square plus 3x plus 10 are the zeros of a cubic polynomial are of the form a plus b and a plus 2b, where a and b are some real numbers. Find the values of a and b as well as zeros of the polynomial. You have to find the values of a and b as well as zeros of the polynomial. Okay, we'll take some examples. Now, see here. P of x equals to x cube minus 6x square plus 3x plus 10 are of the form a plus b and a plus 2b. These three are the zeros of the polynomial, where a, b are the real numbers. You have to find the values of a and b as well as zeros of the polynomial. Now, first we take the relation between zeros and the coefficients. Okay, the sum of the zeros. See here, let alpha equals to a, beta equals to a plus b and gamma equals to a plus 2b. Now, sum of the zeros, that is alpha plus beta plus gamma equals to minus b by a. What is alpha here? A. Beta is a plus b and gamma is a plus 2b equals to minus, what is b over here? Minus 6. The coefficient of x cube is 1. Okay, so a plus a, 3a. b plus 2b, 3b equals to 6. So, a plus b equals to 6 by 3, which is 2. Take as equation 1. Then, product of the zeros, that is alpha. So, product of the zeros. That is alpha, beta, gamma equals to minus d by a. So, alpha is a. Then beta is a plus b and gamma is a plus 2b equals to minus d by a, minus 10 by 1. Now, a into a plus b is 2. I will substitute equation 1 in place of a plus b. Then a plus 2b you can write as a plus b plus b, right? b plus b is 2b. So, which is minus 10. So, 2a a plus b is again 2 plus b equals to minus 10. Now simplify. Now b is what? B is 2 minus a. So 2a bracket 2 plus what is b? 2 minus a equals to minus 10. This is from equation 1. Okay. So 2a into 4 minus a equals to minus 10. So 4 2s are 8a minus 2a minus a is 2a square equals to minus 10. Take all the terms to right side. 2a square minus 8a minus 10 equals to 0. Divide whole equation by 2 to simplify. So a square minus 4a minus 5 equals to 0. Now factorize this by splitting the middle term. A square minus 5a plus a equals to 0. So a is common. A minus 5 plus 1 into a minus 5. So a plus 1 equals to 0 and a minus 5 equals to 0. So that a equals to minus 1 and a equals to 5. So you got two values for a. So one is minus 1 and the other one is 5. Now using these two values also we have to find the value of b. So when a is minus 1, a equals to minus 1, then b equals to. So a is minus 1, then when a equals to minus 1, then a plus b equals to 2. Right? This is the equation 1. A is minus 1, then b equals to 3. When a is minus 1, b is 3. When a is 5, when a equals to 5, then b is 5 plus b equals to 2. b equals to 2 minus 5. So which is b equals to minus 3. So when a is minus 1, b is 3. When a is 5, then b is minus 3. Therefore, the three zeros are. Therefore, the three zeros are. So one is a, find out. Other one is a plus b. And the third one is a plus 2b, which is minus 1, 2 and 5. Substitute a and b values, you will get the three zeros of the given polynomial. At first what we have to do? We have to use the relation sum of the zeros and product of the zeros. Using these two relation we have to find out a and b. Here a you will get two values. So for those two values find out b values. Using this a and b values find the zeros of the cubic polynomial. I hope you understood this. We'll take one more example. Second example, if one zero of the polynomial is 0, one of the 0 is 0. One of the 0 is 0 and the polynomial is ax cube plus bx square plus cx plus d, where a not equal to 0, then the product of the other two zeros you have to find. So product of the other two zeros. Product of the other two zeros you have to find. So one of the 0 is given as 0 of a cubic polynomial ax cube plus bx square plus cx plus d, where a is not equal to 0. So we have to find the product of the other two zeros. So this is a cubic polynomial. It has 3 zeros, at the most 3 zeros. So in that, one of the 0 is 0. So find the product of the other two zeros. So let alpha equals to 0. Because it is given already, one of the 0 is 0. Then sum of the zeros, that is alpha plus beta plus gamma equals to minus b by a. This is the first relation. Then the second relation is what? Sum of the product of the two zeros taken at a time. That is alpha beta plus beta gamma plus gamma alpha equals to c by a. This is the next one. What is the third relation? Alpha beta gamma equals to minus d by a. Now we need to find product of the other two zeros. So other two zeros, so which relation we can use? It is better to use this equation, because here one of the 0 is 0. So 0 into any number 0, Again that the same 0 is repeated here. So this term also 0, right? So that we can use this relation to find the product of the other two zeros easily. So other relation also we can use, but the process, the steps, you will get more steps to simplify. So better we'll go for simple steps. So alpha beta, here one of the 0 is 0 plus beta gamma plus gamma alpha equals to c by a. So which is 0 plus beta gamma plus 0 equals to c by a. Therefore, product of the zeros is c by a. So one more question will be asked in board exam. One of the 0 is 0. Find the product of the other two zeros. So product of the other two zeros is c by a. I hope you understood this concept of cubic polynomial. So once again, revise all the sums which is given in textbook. Thank you, students.